Hi everyone, and welcome to our video on consumer and producer surplus. So in these videos, we're looking at the supply and demand curves. So if you have to take economics, or if you are taking economics, they're a big part of that class, and they will explain things a lot better than I can, but we will just make sure we can do the calculus parts of what we would be doing with these curves. So the consumer demand curve, let's highlight that in blue, is the graph of P equals D of X, which is the price per unit P that a consumer is willing to pay for X units of a product. Okay, so our demand curve is usually a decreasing curve. I'm marking it here in the blue. I don't like that. So there, it usually is decreasing, so downward from left to right. And here it is, got a slight curve to it. Now in economics classes, it might be a line. That's fine too. Okay, so it just depends. A supply curve, let's do that one in purple. A supply curve is the graph of P equals S of X, which is the price per unit P that a producer is willing to accept for selling X units. It's usually an increasing curve, so upward from left to right, right here. Well, where the two curves intersect is called the equilibrium point, and it's an x coordinate, and then the P, so that's our y coordinate. So notice our price is the y-axis. So that's our y-axis price, and then our units, that's the x-axis. Okay, so they're still using x for the x coordinates, but p for y coordinates, and they just do a little subscript e for equilibrium. It is the intersections of these two curves. All right, here, just making an extra big dot. And let me even label it here. There's our equilibrium point. Okay, so we have our equilibrium points, and notice how they marked it on the x-axis. So XE is also marked here, and then PE is also marked here. Because we know those are horizontal and vertical links that we can mark on the axis as well. All right, well, there is our supply and demand curves graphed, and then notice in our calculus part, we've got some shaded area where above this dashed line, so the consumer surplus, that is this portion that I'm trying to highlight right here. Okay, so that's our consumer surplus, and it is given by this equation. Let's go ahead and put our consumer surplus equals. So it's given by this equation where we have an integral, and it really is just the integral. So if we break it down using our rules for calculus, it's saying this here that I'm underlining. This integral portion, d of x dx, would be the area under the curve. Now it would be, I'm going to erase this in a second. I'm going to erase this that I'm drawing in. That would represent this area. So that first part is representing this area. But I don't want this whole total area, so that's why I'm going to erase it. Okay, we don't want all of it. We only want the highlighted portion, so we would have to take away the area of this rectangle. And that QP is the area of that rectangle. Okay, so they might say this is Q and this is capital P. Now for an usually we're doing it at the equilibrium. Okay, so instead of that equation, we might just change it right away to be the XEPE multiplication. Okay, so usually our consumer surplus, we're looking at it at the equilibrium point, so we can modify our equation if we want to. Okay, so that's all this part is the area of that rectangle. So this is the area under the whole curve. And then this was the area under that rectangle. Okay, so that's all represented. Okay, and then our producer surplus. So our producer surplus, I'm gonna, let me do striped lines. So this is our producer surplus in this part of the graph. So that's our producer surplus, doing the dashed lines next to it. And let me mark our equation also. Producer surplus is equal to this. So again, it's saying this part is the area of that rectangle, the same rectangle. area of the rectangle, but the whole area of the rectangle, all of it below, so I'm going to delete this again in a second. That would represent this whole area, but we don't want all of that area. We only want what I did as the dashed marks, so let's erase that now. So we would want to take away this blank spot, and that would be taking away the area under the purple curve. Okay, so that's what this part represents, area under supply curve. Okay, so that's it. And just like the other one, the QP, we could change it. So I have it marked on the graph. It is still usually at the equilibrium point. We can change those to be the x coordinate times the y coordinate there. And then we'll change that if we want to. Or we could just label it Q and P, or you could still just think like, oh, it's a rectangle, whatever works best for you. Okay, so those are our different equations. Whoop, I freaked out. There we go. Okay, so those are our different equations. So let's try using it on a problem. So I've got two problems here I want to work on. And I just gotta scroll so it's all on the next page. Okay, so in these problems, we're gonna sketch graphs of our two functions. So it says d of x is equal to negative 5, 6x plus 10 is the price in dollars per unit that consumers are willing to pay for x units of an item. And s of x is equal to 1/3 x plus 3 is the price in dollars per unit that producers are willing to accept for x units. All right, so I'm going to make the sketch over here. Okay, so d of x, let's mark that in blue. And this, we can use Desmos or a graphing calculator to see it. This is just a line though, so it does have a y-intercept of 10, and then it does have a negative slope. So something like that. Okay, so this is our d of x graph. And let's label the x-axis. So the x is the units. And then the y-axis, again, is really the p-axis, price. Okay, and then we have s of x. Let's do that one in purple. S of x is 1/3 x plus 3. So that's also a line. It has a y-intercept of 3, and then it has a slope of positive 1/3. So it would go up to the right like that. Okay, so here's our s of x. All right, and then what we need to do is find the equilibrium point. So that is it right here. So again, Desmos can find it probably very fast or compared to what we would do, but let's make sure we can still do it with algebra. So to find the equilibrium point, that is where the two functions are equal to each other. So we'll just set the left side as negative 5, 6x plus 10, and s of x will be 1/3 x plus 3. And then we have to solve this. Okay, so because the denominators in our fractions are common with 6, I'm going to go ahead and multiply everything by 6 so I can see it without any fractions. And so if I multiply everything by 6, the 6 and 5 6 would become negative 5, and then x is attached, plus 60 equals 6 times 1/3 would be 2, and then x is attached, and then 6 times 3 is 18. Okay, so we have this set up, and then I'm going to subtract the 2x over to get negative 7x, and I'm going to subtract the 60 over to get negative 42. And then when we divide by negative 7, we're going to get x is 6. Okay, so far I have my x coordinate, so that's the xe. And then I need to find the y coordinate. Well, to find the y coordinate, I just need to plug my x value that I just found into my function, or either function. So it should work for both since that's where they're equal to each other. So if I do s of 6, that should give me the same thing as if I did d of 6. Okay, so I'm just setting them both up. Okay, and it doesn't matter which one we do, they do both equal 5. Okay, so again, that shows that our x value is correct. So we have 5. Okay, and that would be our equilibrium y coordinate, so PE. And so if we want to, we can even mark it, here's 6, and then here's 5. Okay, so marking it, the x coordinate on the x-axis, the y coordinate on the y-axis. And then from here, it might be a good idea to draw in that dashed line like so. Okay, because now we've got to figure out the consumer surplus. I'm going to mark that in green. Okay, so the consumer surplus at the equilibrium point. So the consumer surplus, that is this area right here. Okay, so at the equilibrium point. So consumer surplus at the equilibrium point. Again, that's usually what's common in these problems. Okay, so if they wanted us to do something else, I mean, we could move our x coordinate around, and it's not much different. Okay, but typically it's at the equilibrium point. Okay, so that I need to find that area. Okay, so the consumer surplus is equal to, okay, so I'm just trying to think, it's the area under the curve of the demand function, the blue curve. So we have d of x dx, and then I want to go from 0 to the x coordinate, so 0 to 6. And then I would want to take away this, let's do that vertical dash line too. I would want to take away the area of this rectangle that I currently have. Okay, so I'm going to label that XE and PE also there. So that would be minus the multiplication of that XE PE. Okay, so that's the setup. And then now we'll continue with it. Let me change my color to black ink. Okay, so I'm going to rewrite. So d of x, we have, d of x is negative 5/6 x plus 10. And then dx is just telling us how to integrate it. And then minus xe we have is 6, pe we have is 5. Okay, so we're just making sure we can integrate this this indefinite integral from 0 to 6. And when we do, we've got, all right, so I know we need to add to 1 to the power there on the x, so x squared. And then we would divide by 2 or multiply the front by 1/2. That's how I'm going to do that. Okay, so that's the first. And then the antiderivative of 10 would be 10x. And then we need to do our our bounds from 0 to 6. And then minus 6 times 5 is 30. We just write that. Okay, so now we need to plug in, well, let's simplify the 1/2 times negative 5/6, and then we'll plug in. So we have negative 5/12 x squared plus 10x, and then still the bounds, 0 to 6. Okay, so a little tight on room, but we would plug those in. Remember, it's always the top one going in. So we would have negative 5/12 times 6 squared plus 10 times 6, always minus the bottom one going in, minus negative 5/12 times 0 squared plus 10 times 0. And then still just minus 30, just don't want to lose track of it. Okay, and I wrote a little big, so we'll have to write our simplified thing over here. All right, so simplifying the green part, remember we would square first, so 6 squared is 36, so we'd have negative 5/12 times 36, and then 10 times 6 we can do is 60. Everything in the pink is 0, so 5/12 times 0, okay, so all of that's 0. So I'm just going to write minus 0 just to show a placeholder, and then still minus 30. Okay, so still just keeping track of everything. Okay, and then we do have a fraction here that would simplify. And again, we could use a calculator to help us with this at this point, but it would simplify to be negative 15, and then still plus 60, still minus 30. And then when we simplify it all the way, we get 15. Okay, so the consumer surplus is $15. Okay, so that's it. Okay, so we found it. Okay, so that was the area under that curve there. All right, so big setups. And then let's take care of this producer surplus as well. All right, so the producer surplus, let's do that one in blue. Or no, we already used blue. Let's do it in purple. Okay, so, oop, I freaked out. Sorry, let's scroll. Okay, so the producer surplus, that's under the supply curve, or not under the supply curve, it's under the dashed line in between the supply curve. Okay, so I'm going to do my squiggle. Okay, so that is the producer surplus. Okay, so that's our producer surplus in that little area. Okay, and one thing that might help, knowing where to go with it, like consumer surplus and demand, those are close together alphabetically. Producer surplus and supply are also close to each other alphabetically. Okay, so just to make sure we know which curve is which when doing consumer versus producer. All right, so now that we've got it though, just at least listed, I need to find the area under the curve, which is still the area of this rectangle, which is still 30. Okay, so we could just write in 30 if we want from the previous step, or we can set it up all the way. Let's set it up all the way, and then we'll minus the area under the pink curve. Okay, so we've got the producer surplus is equal to, we said it's the area under the rectangle at the equilibrium point. So I'm going to do XEPE minus the area under the supply curve, so this slanted line, which would need to be using an integral. Okay, so we can see the bounds are 0 to 6 still. It's that the beginning x-coordinate to the ending x-coordinate. And then we need to put in the supply curve. Okay, so we're going to do 1/3 x plus 3 dx. Okay, so that is the supply curve that we're putting into the integral. Okay, and then now again, we're simplifying. Our XE was 6, our PE was 5, minus, and then we can start to do this integral. Okay, so I would have 1/3. I know I should add 1 to the x power to get x squared, and I should multiply the front by the reciprocal. Okay, so 1/2 times 1/3 x squared, and then the constant, I should put an x with it. And then we just need to put our vertical bar 0 to 6. Okay, so there's our big setup, and I'm just going back to black ink because I think it might be better. 6 times 5 is 30. And then we still have minus. Keep those parentheses. Okay, so make sure, because this minus will distribute, but we want to do our full evaluate the integral first before we distribute. So let's simplify that fraction. It is 1/6 x squared plus 3x. But we still need to put those bounds in. So just like always, it is the top one minus the bottom one. Okay, so we're going to have 30 minus, I'm actually going to do a big bracket, and then now I'm going to plug in the 6 into those x's. So 1/6 times 6 squared plus 3 times 6, all in the purple parentheses. And then always minus the second one, minus 0 going in, so 1/6 times 0 squared plus 3 times 0. And then now I'm going to put my big bracket again to say I've got it all set up. Okay, so I need to simplify all of this, and then the minus will go through. So we've got 30 minus, keep the bracket. Using a calculator, again, would help this go a little faster. I'm going to do it mentally here. So we have 6 squared is 36. Divided by 6, though, would give us 6. And then plus 3 times 6 is 18. Minus, everything in that pink happens to be 0 again. Okay, so we can do the 6 plus 18 to get 24. And then now we can do the minus. Okay, so we get $6. Okay, so that is the producer surplus. Now, chances are it's with a word problem, so we could make more sense out of it. And it would probably be in like thousands of dollars instead of what we found as like $15 and $6. But I mean, that's making it to where we have nice equations, though, with easier numbers to work with. All right, so that's it. If you do have questions, please let me know. Otherwise, thanks for watching, and we'll do another example in the next video. So see you then.